Hey YouTubers and vintage guitar amplifier lovers, welcome back to my channel about my Time Bomb amplifier, Time Bomb 2, the one which is consisting out of tubes from an older Russian radio. Actually these tubes were all constructed in the 1930s. Actually they were manufactured around the 1960s, and now they found their way from an original radio into a metal amplifier. Just to show you in quick what we have here, because I was really shuffling around with the order of the tubes and which tubes are used at all. So starting here, this is the input tube. This is a heptode or a pentagrid converter, so it has 7 grids in total, including plate and cathode. And that one is now driving this beautiful, let me get it a bit more closer here, this beautiful triode. Actually, of course this amplifier should be all pentodes, but since I had this still as a NOS part in stock and I had one free tube socket here, I decided I put it in. And actually I was a bit short on gain, and that helped me. I mean, this is a medium gain triode with only an average amplification factor of 15 to 20 but this is enough to really give me that extra amount of gain which I need for a high gain metal amp. And then the third tube in the setup is a low microphony pentode, a sharp cut off pentode, so just a standard pentode. Then we have the driver pentode here. And finally we have the output pentode, which is the Russian equivalent to a 6v6. And finally here we have the rectifier tube. And brand new is now the indicator tube. I need to switch off the light here. Yeah, so this is now my indicator lamp. You might remember this from Time Bomb 1, and if I turn on the amplifier, then whoops, it comes up with a really nice and bright green. So you might wonder how I get my hands on such a brightly glowing indicator lamp. Actually a light or a tube. Actually I tell you, this was a pretty old tube and it was worn out already quite much, but I used a little trick. Of course this trick was not invented by myself, but it's a quite common trick for boosting the brightness of these indicator tubes. I will show you here in my circuit diagram. The part is basically here. This is a voltage multiplier, a cascade, and so we're basically taking voltage here, the 250 volt from the primary transformer, and here with these capacitors and the diodes the voltage is multiplied and we get a whopping 525 volts under load DC out of it, and from that we drive the plate of this excuse me, we drive the plate of this indicator tube. So this is a common trick. A couple of tubes only use 2 stages here, but since I needed this 500 volt to really light it up so nicely, I decided I add this third stage here with a third capacitor. These capacitors have something like 630 volt each DC resistance, or DC, they can stand 630 volts, and with that, this is quite impressive now how bright this tube is glowing. And actually, talking about theory, then I mean, it was a quite hard way to get to the amplifier where it is now. I mean, I was studying a lot of data sheets here, these Russian data sheets, the original one from the radio, some load curves and some theoretical calculations I did for all these different tubes, because I really had no experience with them any before. They were completely new to me, and they are pretty far away from the standard ECC 83 or even the EF 86. Oops, there it goes. And luckily, most of the tubes have American equivalent. For instance, this see, this is the triode. Yeah, so this has a American equivalent, so I could use that data sheet. Makes it easier for me to understand. Yeah, and then going through through different circuit schematic approaches. This one is version 1.2, and you see I marked a lot of things in orange or in blue where I thought something needs to be changed. It's about changing capacitors, make them larger, make them smaller, even changing the order of the tubes. I mean, that was a very early approach where I thought that this low microphony pentode could be the first, while the while the heptode pentagrid converter could be the second one, when I found out that the pentagrid converter is very sensitive, while this this pentode here needs roughly 10 to 20 volt at the grid to really operate. And so I decided to change between both tubes. So this one is now in place in the first tube, and that one is the not even the second one, because in a later version then I changed, I added a triode, but I also changed the position from the triode to the second place. So I think now we are here at the, that's even another version, and that's, yeah, it's not final, but it's version 2.5. So now you see here on the schematic, this is the pentagrid converter, which drives then the triode drives the pentode drives the pentode, the tone stack here, and then the output pentode single-ended, and there is the indicator tube, and here we have the rectifier tube. So this did not really come overnight, and it was a lot of work and experimenting with the proper operation points of the tubes, also finding the right capacitors and finding the right resistors, anode resistors and everything, because this is really, let's say, new territory. The way this amp is working, mainly of course because it has so much pentodes inside. And probably I can, let's take a look under the amplifier. Keep in mind that is experimental amplifier. Oh, by the way, did we now see the voltage? I can't remember the voltage of the plate voltage of the indicator lamp, indicator tube here. So 600, 580, 570 as the filament is heating up, and when it's operating, we should be somewhere at 525 volts. So this, you see my two probes here where I'm checking the voltage. That is of course a part I need then to cover very firmly, because nobody probably wants to touch 500 volts. This could be a not so pleasant experience. So nevertheless, let's switch off the amplifier and take a look. Let's take a look under the whole thing. Oops. I'm trying to get my camera. There is a resistor bridging the main electrolytic capacitors inside, so I'm very sure that there is no remaining current inside, and that I don't get zapped when I turn the chassis. Okay, so where is my pointing stick, and do we need some more light maybe? Let's see. Yeah, so that's how it looks like currently. Halfway nice. I mean, I'm not really a fan of this, how to say, microscopic accurate design. And second, this is a new layout, so I had to change from here to there some things. But of course I try then to have the filaments always twisted here, and I tried then to use some 90 degrees angles, which makes things look so nice here. Also I tried it every now and then, but on the other hand, for instance, these resistors here, I just added them because the initial values were not enough, and partly they came from my spare part pool, or of course they come all from my spare part pool, so that's why they don't look all the way the same. And I'm using also different capacitors inside here, this German Weimar, and then also some other capacitors I probably had from spare parts. I cannot really remember. The high voltage cascade is now this thing here. You remember this? It consists of diodes and capacitors. The diodes are underneath because I really wanted to construct it in such a way that you cannot touch any high voltage here. And actually, you see there's a second PCB under it, which protects even then from the diodes from arcing towards the chassis. So any high voltage components are placed between these two PCBs, and that is then connected to the hard to see now through this hose here, this white wires, and this shrink tube connected then to the to the secondary leads of the mains transformer. Yeah, what else? Let's see. I still have these pots here. Now these, in Germany we call them trimmers, to adjust the operation point of the cathode bias. It's very helpful because it really has a big impact on the sound. Yeah, so that is the input tube, and here next time I'll probably use some more of these turret boards or these I don't even know how it's called, PCBs with some standing up connectors on top, rather than this point to point, because in point to point, if you have to change something, it can be quite cumbersome. You see in this tone stack there are a couple of components now, and it's not so easy to change things afterwards. Also, the soldering can be still improved a bit. Unfortunately, my fantastic Vela is running, the tip is a bit worn out, and I'm not sure how I can get here in the city some replacement. Yeah, that one is new. That is a trimmer for the for adjusting the angle of the indicator angle of the indicator tube. Yeah, and that's it more or less from the inside. By the way, this big body here is the resistor, which is bridging then the central capacitor, and which is then discharging the capacitor. It's what is it, 120 kilo ohms. So within a few seconds, and this main capacitor should be discharged. Now you might ask then, how's the sound? And I can only tell that I'm more than happy with the sound. It's got now so much gain on the tap. So with these 4 preamp tubes, it's got really a lot of gain. And previously I had also a problem with the output transformer, because I was telling in the previous video that the the bass frequencies were pretty low, or let's say the height, the trebles were, let's say, over accentuated, and it was really a problem of getting the right output impedance for this body, because in the original circuit diagram, this transformer, I can show you this circuit diagram here. This transformer was driving two parallel speakers, and assuming these speakers were only 4 ohms, so we have an output impedance here of 2 ohms. And also, if you calculate the current and the operating voltages, you would see that then I also measured the Übertragungsverhältnis, the transformer ratio of this body. It is 56, which is really high. So I think here I needed something like a 5, 6, 7, I forgot, kilo ohms resistance, and with this 56 transformer ratio, you end up here really only with 2 ohms. So what I did in reality, first of all, I rewired my Marshall cabinet. You know, these big Marshall cabinets usually have 16 ohms. But what I now did is, you see the sticker, 4 ohm. So I wired all the 4 speakers in parallel, which gives me then 4 ohms. And then I was experimenting with some additional resistors, plain resistors, in parallel to the output. And boy, that gave a big difference in the frequency response of the output. The more load you put there, of course the lower the volume gets, but the more the bass frequencies are emphasized. And with that, I was just trying to tune the whole thing in such a way, since at the moment here in Russia, I'm not sure how I can buy another output transformer. So for the moment, I'm just staying with what I have here, and to get a good frequency response with the 2 ohm, I have now the cabinet on 4 ohm, and I have another 4 ohm in parallel, which then gives me on the output the required 2 ohms. Yeah, and sound wise, one more thing, I found out I had quite a hum, and still there is some hum when you turn up the gain. That is mainly coming here, of course, from the first tube. I need to still check if this has a separate shielding somewhere on the socket. I did not recall anything that this metal casing is somehow grounded. So that is something I need to find out. But I applied a DC filament heating here in my schematic. Yeah, it's here on the bottom. So tube 1 is now heated with DC, and that made a big impact. I was measuring the hum coming out of this tube, and with the AC, I found out it was more than 50 millivolts peak to peak humming, and after I applied the DC, there was only less than 20 millivolts, so less than 50%, more than 50% reduction. Yeah, and now let's give a shot. One more thing I did also, I was reworking the tone stack, because I had one capacitor inside which was labeled like 10 nanofarad, but I had my doubts that it was a proper value, and I just soldered it out, and I put another 10 nanofarad inside, and boy, there was a complete change now in the stack. So obviously this body had a wrong label on it, or I misinterpreted what was printed on it. You never know, these things have sometimes really strange labels on it. So, but once again, we have more than enough gain, and I will show you if I find my guitar cable. Yeah, here it is. So the input is now here on the left. It looks a bit nicer because formerly it was here, but it was too crowded, everything. So, and it looks much better from the left. And gain, the tone stack, master volume, and standby, and the main switch. So I think it looks better. And move it a bit to the front here, this thing. Okay, so then, and pardon me for playing always the same riffs. I mean, at the moment I'm pretty much concentrating on this amplifier and building the amplifier, and not so much on playing with my band and creating new riffs. But okay, let's just give it a shot. Oh yeah. quite a lot of gain, and that is pretty much what I wanted from this amp. Still some fine-tuning on the operating points of the tubes must be done, shall be done. Also there's still a little bit of muddiness, which I will try to fight with some smaller capacitors. But now this indicator lamp here, oops. Quite loud here in my little workshop, but you got the idea how this thing is working. And then the tone stack is now much more responsive. Let's try. Right now we had the, let me see, can't see anything here. I need to switch on the main lamp. Yeah. So what do we have here? Yeah, you see the mids are pretty much scooped. So we are here at 9. The bass was at 3 and this was at 2. So let's give it a bit more, or let's just turn everything to minimum. A little bit less gain here from the guitar. Now sounds like a medium wave radio, so we throw in a more bass. And here I still hear a little bit of mud, so probably I still have to look over the capacitors, coupling capacitors and cathode capacitors. Then the mid, which was not really working before, but now it is. Yeah, hooray. And then we crank up the treble. I can only say it's really fun playing this amplifier. I really like the sound very much. So that was everything on max. And if you do maximum scooping, yeah, and on the German tube forum somebody was asking whether it can also do blues, and and I replied, well, it probably can do, but I can't do, so I'm not a blues guy. So what I will just check, if I just turn down the gain, and probably for blues, I'm not think that blues uses scooped sounds. So I would say a blues amp like a JTM45 sounds probably different, but that was not why I designed this thing. So I wanted to have a pretty unique sound, and personally I really like this only like this full gain sound here, and for that I'm really happy. Yeah, so that was an update, almost final with this thing. Probably I'll have one or two more videos with some more updates. Actually, of course, the labels are still missing here and a little bit of beautifying, but so far I would say the construction work is almost done, and I might have to fight a bit this humming still, which we have when we turn it up. But so far I'm really happy. Thanks for watching, folks. Stay tuned for more. And actually, one more thing, there will be a third time bomb coming because I bought on a German flea market this crazy thing here. It's 15 watt push-pull amplifier, probably some measuring equipment, I don't know what, but that one will become Time Bomb 3, also once again only made out of pentodes, no triodes inside. But let's first finish that one here and then see what's going on. Alright, once again, thanks for watching, take care, stay tuned and heavy, bye.